Hi, Rory. Hey, how's it going?
Hi, how are you doing?
I'm good, thanks. Good.
Good, good.
So, FarmBot. I don't even know where to start. How did you actually come to be making a robot for farms?
Sure. I took an organic agriculture class at my university about 3 years ago,
Yeah.
uh, because I've always, been in the garden and I wanted to learn more about it. I wanted to learn more about the different ways you can grow food, about the system as a whole, kind of the state of the landscape of industry, all that good stuff. So I took that class and we had a guest speaker come in who was really excited to tell us about his new tractor, which had this special tool on it. It was a camera and this kind of pirate's hook tool that would stir up the ground and essentially destroy weeds. And every time that the camera detected a lettuce plant, the pirate's hook would sort of skip around it.
Right.
And I saw that and said, and I studied mechanical engineering. So, from kind of an engineer standpoint, I said, hey, I think I could do that better. And so I came up with this idea, well, what if we put the tractor, sort of traditionally this free driving machine that a human drives, what if we put it on tracks and made it more like a printer where it was moving very precisely. And we took the human out altogether. We said, let's just control it with a computer from the get-go. And just like a printer, it always knows where the print head is in relationship to the paper. That way it can deposit the ink in a very precise spot. And so that's sort of the premise of FarmBot is let's have our tool, either the pirate's hook or the seed injector or watering nozzle, and put it on this very precise system that moves back and forth in the XYZ space and grow the plants that way. And then over the years, over about 2 years, I sort of just thought about the idea, did some research, and the benefits started to unfold about how this system could be really great. And then, but that was sort of the initial idea was just let's put the tractor on tracks.
So essentially, you've the system as it currently stands in its current sort of stage of design is, you've got tracks to give it the ability to move over a surface. Can it move over fields or?
Yeah, so the tracks you could mount them to a raised bed in your backyard. You could mount them to the walls of a greenhouse, on the top of a roof, or even in a field. I'm not sure how well it will do. I mean, it will definitely take some design modification to make it work well in a, like a slopey, bumpy terrain.
Yeah.
But in a flat field, I think it should do just fine.
And essentially, then attached to this, because I've just been looking at the picture of it on your website, you've essentially got what like you described as like almost like a print head that can move from side to side, and the whole thing on the tracks can move forwards and backwards. So you've got that XYZ direction. The print head, if you like, can move up and down as well.
Yeah, definitely.
Brilliant. So what sort of uses do you think? What are the main uses for it? You mentioned a couple before, but are there other uses?
You mean outside of agriculture?
Well, just in general. So I guess particularly in agriculture, but also outside of agriculture as well, I guess.
Sure. So, I mean, I think the use case that I'm most interested in is this at-home uh, automated gardening system, or maybe like an urban rooftop or a greenhouse. So essentially, a system that you would it'd be sort of this plug and play kit where you purchase it, you assemble it together with like one screwdriver, no soldering required. You plug it in, you hook in your hose, and then you put some seeds into some type of container somewhere. And then you go onto the computer, and it's this very straightforward, easy, almost gamified interface where you design your farm or garden, and then you basically just send it to the robot. And the robot does its thing for the next couple weeks or a couple months, and then it will send you notifications via phone or email when maintenance is required or the tomatoes are ready for picking or whatever it is. And so, really looking towards kind of a completely automated system that would enable people to grow their own food at home, have complete control over the process and kind of the inputs of that food, and not have to put in as much time and effort and labor and knowledge into the actual production.
I guess it could be used in sort of industrialized food production as well. You know, planting seeds, things like aquaponics, hydroponics. There's a lot of options there because you've already got fairly uniform growing beds and things like that because of the overall setup. So I'm guessing it'd have a lot of uses in that sector as well.
Definitely. I think the design intention could scale quite large. I think, there's no reason why you can't make the tracks instead of 10 feet long or 10 meters, several kilometers long, um, you know, ex ex spreading out over huge fields. There's no reason why it couldn't be that big. I'm personally not interested in developing the really large systems, but it's open source, and so anybody can do that, especially if there's a great market opportunity for it. Then the other, just off topic, kind of other uses of this system, people have talked about using it for archaeology, where you could almost reverse 3D print something. So you have, instead of, a seed injector, you have a little drill bit and like a vacuum that you could suck away dirt, and it would almost reverse 3D print where it's removing all this material on an archaeology site, and then it's also 3D scanning everything, and then you could very precisely dig up stuff.
And it'd be a lot quicker as well than the conventional approach. Yeah. Um, I mean, I guess it could be from what it sounds like. You could use it for like a whole range of different things. Anywhere where you need this sort of XYZ motion on a sort of fairly fixed position. One of the other things I was thinking, back to sort of agriculture again, is there's quite a few farms that are sort of circular in design, and they have like this big sort of rotating arm that's connected in the middle and then rotates around the radius of the field. With some modification, could it be fitted to something like that so that the main arm is moving it around the field and it just moves up and down the arm and then sort of in and out of the field?
Definitely. In fact, we actually have a design like that somebody submitted onto our wiki. Uh, so the current design is the Cartesian coordinate system, X, Y, and Z, and then we could also do that polar coordinate version of radius, angle, and Z. And I think both designs are great. I think it depends on the application. For instance, it wouldn't make a whole lot of sense to do the polar coordinate version inside of a square greenhouse, um, or try and do it maybe in somebody's backyard, depending on the shape of their yard. I mean, who knows? But I think that the circular version would be great in certain applications, like especially on something larger. Um, and I hope that people develop that. And the software that we're developing could be used, pretty much the same software could be used on both the polar version and the Cartesian system. There'd essentially be at the lowest level a simple transformation of the coordinates from Cartesian to polar. It'd actually be very simple to program it that way. Um, so I think that's a great idea, and it's something that we want to explore.
So, in terms of the components, been looking on your website again, there's quite a number of them in terms of the hardware and software. Could you tell us a bit more about those?
Yeah, so it is a very complex system. So we have the FarmBot project is a hardware, software, and data project. So of course we have the hardware, which is the physical robot. It has stepper motors and an Arduino microcontroller, sort of an open source little prototyping platform that controls the motors and receives the commands from the computer. The computer that we're using is the Raspberry Pi, which is also an open source little cheap computer. So essentially we have that's the hardware. We have the Raspberry Pi is the computer. It controls the Arduino, which actually moves the motors and reads the sensors and does all that stuff. Uh, And then as you saw from the pictures, the hardware is this XYZ computer controlled gantry system. So then the software, we have several components. The first coming from the user is a graphical interactive designer that will be on the web. So we're developing this essentially gamified version of how to program the robot. If you're familiar with the game Farmville that got popular on Facebook a couple years ago, kind of like that, sort of a drag and drop interface where you can drag different plants in, you can learn about the different plants, uh, and you design your whole farm or garden and you set all the specifications and then you just press send to the robot and it does its thing. So that's the first component is this graphical designer. And then under the hood of that, the sort of the back end system is pretty complex. Of course, we have the typical web application things like email notifications, user account control, authentication, and the user's data. But we also have a component called the decision support system, which I haven't even figured out a good way to describe it yet quickly. But essentially, it's a bunch of different modules that bring in data, and then they modify that data, and then send that to the robot. So it's best explained with an example. For the first module would, let's say, be the seed spacing module. Let's pull in how far apart should we grow tomatoes. And then we'll have another module below that that says, okay, how should we change the seed spacing based on our soil type? And let's say it's rockier soil and we should maybe space it the tomato seeds farther apart. And so it modifies that initial value. And so we've modulated it somewhat. And then maybe there's another module that says, okay, how do we change seed spacing based on where we are in the world? So maybe maybe we're right near the equator and there's a lot more sun. The plants can be spaced together and still be healthy. So then we'll change that value for seed spacing again. And then the last module basically sums up all of the changes and spits out this optimized number for seed spacing based on all of this different data streams. So to sum up some of the different data streams, we of course have sort of our default values for seed spacing and watering amount and optimal soil conditions, all that stuff. We have the weather. We have past history of the soil in the farm or garden. We have sensor data that the robot actually took, so moisture content, pH, and even potentially the values of some of these nutrients in the soil. So we have all these different values or all these different datas that we pull together into this decision support system, and we optimize each different, I guess, specification on how to grow the plant.
Okay, so it's almost, I guess the sort of closest thing I've heard to something like that. It's almost like a fly-by-wire. You know, in aeroplanes where they've got all these different computers making different decisions, and you've got this central system that sort of brings it all together and decides what to actually do.
Yeah, definitely. Essentially, there's all these different modules saying, oh, we should plant seeds this way, this way, this way, this way. And then we say, okay, well, let's average them all, kind of thing. And then it spits out the optimized number. Once the decision support system has come to a conclusion about how to grow each plant, then that is what sends the actual data to the robot. And the data will actually be pretty, I guess, low level. It's essentially just going to be a lot of coordinates. So, and with timestamps. So at 9 a.m. on this day, move to this coordinate, and then, suck up a seed, then move to this coordinate, deposit the seed, that type of stuff. So it's going to be pretty low level what actually gets sent to the robot.
And what stage of development is this at? Is it still in the sort of planning stage or in the design stage or implementation?
It's a little bit of all of those. We're sort of flying by the seat of our pants here, but we do have a team we have at least one person working on every different component. So we have a great front-end designer who is working on that graphical interface for the design. We have a guy who's working on the web app, which is sort of the user authentication, the email alerts, and then we have a couple different people working on the decision support system. And so we have a pretty good framework for that. Like I said, it's kind of going to be these vertical columns of different modules that modify a certain value. And so we're currently developing, hopefully over the next 2 months, we'll have a basic system that then we can start adding modules to and just sort of plug in new modules whenever we come up with them. And each module itself should actually be fairly simple because it's only modifying one value based on one other value. And so all three of those components are underway. And we actually, the last component, the controller program that reads the coordinates and actually tells the motors to move, that's more or less done. That was fairly simple.
So if people want to find out more and hopefully get involved, where should they go?
So they can Google search FarmBot, and we should be the first thing that pops up. And from our website, there's a couple of different areas that you can contribute. The first spot would just be the forum, where you can jump into conversation and help with the brainstorming. The second place would be the wiki, which is where you can share links and almost little write-ups about certain ideas or technologies. Or if you are in fact developing some of the hardware, you could write about that, share some photos. And then the third place is on GitHub, where we host all of our software. And you can just go on there, browse around the repositories, it's all public. And you can clone it locally and kind of check it out, maybe make some additions or some modifications, and then send in a pull request.
So for anyone who doesn't know, a pull request is essentially if I've made a change to the software I've downloaded, I can sort of give that to you as like a suggestion via a pull request.
Definitely. And then you can also, anyone can always just email me. That's rory@farmbot.it. And I can answer any questions or point you in the right direction.
Oh, that's brilliant. So are you working on any other projects, or have you got anything else planned?
No, not right now. FarmBot is my main deal right now. I'm working on this full time. So I'm actually in my office right now developing some of the hardware today. So I just finished about a week ago the hardware version 2 design. And so I'm going to be prototyping that today.
Thanks for your time. It's been really interesting, and hopefully we can chat again sometime and when you get a bit further along in the development process.
Sounds good.
That'll be excellent. Okay, Rory, thanks very much.
All right, thanks, Guy.
Thanks, see ya.